In this lesson, we are going to be looking at some quadratic word problems. So the first thing we want to do is actually read our problem. In this one, it talks about a carnival game that involves striking a lever that forces a weight up a tube. If the weight reaches 20 feet to ring the bell, the contestant wins the prize. The equation is given to us, which is really important. They're not asking us to come up with the equation, they're giving it to us right here. So that's the equation for the weight going up the tube. It gives the height of the weight if the initial velocity is 32 feet per second. And they want us to graph the equation and then answer the questions. So for us to graph this, you can see this is a quadratic equation. So I'm going to find my vertex first. So I use my axis symmetry, my x equals negative b over 2a. To do that, I'd have negative b over 2 times a. So when I get that, I would have negative 32 over negative 32. So I find that my x-coordinate of my vertex is 1. So then, I'm going to keep going and try and actually find my vertex. So I know that x is 1. So I take my original equation they're giving me and I'm going to find h of 1. So I take negative 16 times 1 squared plus 32 times 1 plus 3. When I do all that simplifying on my calculator, I end up with 19. So I know my vertex for this parabola is 119. If I wanted to, I could plot that point. You'll notice that my graph, let me just show that a little bit better. My graph on the x-axis is going by 1s, but on the y-axis it's going by 4s. So to plot 119, that would be right about here. And yours is going to be a little better graph. Actually, it's going by 2s, isn't it? If I go, let me make it a little bit more in the middle here. There we go. And yours will be nicer because, of course, on the smartboard my dots don't show up as nice. So to move with that, I'm going to make a table. Now, I normally like to make a table from my calculator. So I would punch this data into my calculator, and I would have it do the table for me. So I turn my calculator on, and we do know how to make a table by hand also. You also could use your a value of negative 16, but I don't necessarily know how that works if I don't know that pattern, or I'm not sure. So I think the easiest way to fill up my table is to actually use my calculator to do that, if it ever turns on. So when that opens up, you're going to go to y equals and punch this equation in, and you can use x as the variable instead of t. There's nothing wrong with that. So when I get to this spot here, I'm going to do, just give me a second to adjust something from a different class so it doesn't mess you guys up. So here we go. I'm going to go to my y equals, and then I'm going to go ahead and punch in the original equation. So I'm going to use negative 16x squared plus 32x, and then plus 3. Now, I already found the vertex, so I just want to look at this table and see where my values are near my vertex. So there's my table. I went second graph, and since I know my vertex is 119, I'm just going to go back up to this 1 here. There we go. See how 119 is in the middle? So I know 0, 3 is a point, so it's 2, 3, and then negative 1, negative 45, and 3, negative 45. So I'm just going to copy that straight into my table here. So here's my 119, then I found 0, 3, and 2, 3, negative 1, negative 45, and 3, negative 45. So if I plot those points, 0, 3 is right here, and then 2, 3 is right there. Negative 1, negative 45 should be right here, and then 3, negative 45 is right there. So those are my reflection points. So I'm going to graph this like this, and I've graphed my vertex and the rest of my parabola here. So now hopefully I can answer the questions that relate to this problem. So far it hasn't really seemed like a word problem, right? But now they're going to ask us to decide some things here. So it says, what is the maximum height of the object? If I look at my parabola here, my maximum height, this is how it's traveling. So this would be, on the bottom is my time, and the y-axis here is my height. So these values here are my height. Okay? Obviously, I can't have negative time. So this part of my graph is almost obsolete, isn't it? I'm not going to have negative time, so I don't have to worry about these questions over here probably. I also don't think I can have negative height. So anything below 0 probably isn't going to be something they talk to me about. Does that make sense? So when I look here, when the time is 0, this is where my graph is starting. And what happens is I'm hitting the ball, it hits this maximum height here, and then the ball comes back down. And this is where it drops. That's when the ball has come back down to its initial starting spot. So to answer these questions, I have to understand that about the parabola. So when I'm looking, it says, what's the maximum height? Well, the maximum height would be this highest point right here. And since height is my y values, my maximum height would be 19 feet. And I'm just going to put here, this is the y coordinate of the vertex. That's how I got that. Then it says, at what time does the object reach the maximum height? Well, since x is my time, and my vertex is 119, after 1 second, I've reached my maximum height. And this we got from the x coordinate of the vertex, because x is time. Then it says, what height did the object get released from? How can you tell? So released from means where did it start climbing, and where did the time start? So where my object got released should be this initial point right here. That's where my object got released, because that's where I have my time of 0. This is the time 0, so this is the height it got released at. This ordered pair is 0, 3, it should be. It doesn't really look like a 3. I graphed that in the wrong spot, didn't I? Someone should have. You guys probably already noticed that. There we go. It should be a little wider. I accidentally graphed 0, 2. So 3, 0, 3 is that ordered pair. So what that means is 0, 3, this is when the time is 0, that's the height. So my initial, it asks, went a little too far. At what height did the object get released from? How can you tell? I'm going to say it got released from 3 feet because that's where my time is 0. Or something like that. You don't have to write my exact words. Then it says, how long does it take the object to return to its initial position? So its initial position is right here, isn't it? Where I should have had the 3's. Right in this area. So that's that other ordered pair, the reflection point for 0, 3. Here's where it started, so the reflection point for that would be 2, 3. So that means time is x, so 2 seconds is how long it took it to return to it. So in 2 seconds, the ball went up and back down. It was very quick when I played the game. And I'll say that's my x value for my height equal to 3. It's the other. You can think of it as your reflection point for that 0. It says if the object were to keep traveling, at approximately what time would it hit the ground? How can you tell? Well, where it hits the ground, if this object, let's say, was free falling and not in a tube, the ground would be right here. This is a height of 0. That's the ground. So I'm looking for where my graph crosses the x-axis. If you think about that, that's my roots, that's my solutions, right, where my graph crosses the x-axis. So I'm going to go ahead and do the quadratic formula to find that out. So I'm going to say x equals negative b plus or minus b squared minus 4 times a times c all over 2 times a. Oops, a 16, sorry. So as I continue to simplify that out, I'd get negative 32. Under my radical, I ended up with 1216 over negative 32. When I found this, and normally we try to break down square roots. When I'm doing an actual word problem, it's okay that I have the time. What I'm looking for right now is how much time before I hit the ground. It's okay that I have my time in seconds, and it can be decimals. That's okay. So when I simplify this, I'm actually going to find the decimal value for the square root of 1216. And I'll take negative 32 plus that number, and then divide by negative 32. When I did that, I got x to be negative 33.09 and x to be 2.09. So since I'm looking for how long it took for it to hit the ground, I can't have a negative time, right? So I would say it took about 2.09 seconds. Some people would say a little bit over 2 seconds. I think that would be good enough here, but there's my exact answer for how long it took. So our last question then is, will the player win the prize? So let's look back at what you have to do to hit a prize. To win a prize, the weight reaches 20 feet to the ring to ring the bell. So am I going to get a height of 20 feet? So let's look at our graph. My highest point is right here at 19 feet. I need to get to this spot right here. So this game is rigged. There is no way that I can win this game. The maximum height is 19 feet. So we're going to say no. Max height is 19 feet. And we need 20 feet to win prize. So to win the prize, we could say game is impossible to win. Alright, so they're going to make a lot of money on us playing that game. So there's an example of us using a parabola to answer questions, and you'll notice even though we graphed a parabola, a lot of the information wasn't used because it wasn't necessary. It's still there in the graph, but see all the blue that I crossed out? That information wouldn't have been used because it was negative height or negative time. And we would not have either of those for this problem. Doesn't mean it's never going to be used, but for this problem it wouldn't have applied. If we look at the next problem, it says an object is fired straight up from the top of a 200-foot tower at a velocity of 80 feet per second. The height, h of t, of the object t seconds after firing is given by the following equation. So think about it. You're standing on a tower and you fire this object. So that's where they're getting that parabola look from. Obviously, when we draw the parabola, we're going to add this piece to it. But since there's a tower there, they're throwing it off the tower. So it's going to have that arcing of a parabola. It's going to shoot up and then come down with gravity. So it says find the maximum height reached by the object and the time that that height is reached. So here they're looking for the vertex. So I want you to please pause the video and then find the vertex and see if you get the same one as me. My x-coordinate is 2.5. When I plug that in, I end up with a vertex of 2.5 and 300. So I would say the maximum height is 300 feet at a time of 2.5 seconds. That's how they want me to answer that first question. Now look at your graph. Since they gave you the graph here, does that answer actually make sense? Remember this along the bottom here. This is our height, sorry, y-axis is height, x-axis is time, so seconds. When I look for this vertex, it's right there. Looks like 300 feet, looks like 2.5 seconds. So my answer I found looks like a reasonable answer based on my graph. It looks perfect, doesn't it? Then it says find the y-intercept. The y-intercept is where the graph crosses the y-axis. So that looks like right here. I could plug in 0 for x and find that to get the answer. So now if I do that, I'm going to take x equals 0 to find the y-intercept and h of 0. So when you plug in 0 for everything, which really goes quickly, right? I get a value of 200. Now, I probably makes sense for me to think of that. Think of what they said. There's a tower they throw from. So this is where time starts. This must be where the tower is, right here. So this is my part of my parabola that wouldn't matter. This is me standing on top of the tower shooting that off. And it reaches its max height right here, and then it falls to the ground. That's what this bottom part of this parabola is right there. So when I answer what does that mean in this situation, this 200 feet, that's the top of the tower. And they actually gave that to us in our problem. So if you understand how this works, you could have said that answer without using any math because they told you that you fired it from 200 feet. So that should be the y-intercept. That should be where the graph starts with time of 0. My x value is 0. Then the last question for that one says, when does the object return to the height it was released at? Well, it was released at a height of 200, which is right here. They want to know what value this point is. Now, by looking at my graph, I'm going to say it definitely looks like it's a 5, doesn't it? But if I want to check that, to make sure using my math, let's say it was a decimal. I couldn't really tell. This graph, it's a little easier to see it's a 5. I'm going to plug in 200 for my y value, which is my h of t. So I'd say 200 equals, and then I'm going to keep everything else in my equation the same, because I'm looking for where that y value is 200. And then I'm going to solve this equation. So the first step would be to get the equation equal to 0, which takes my constant away, doesn't it? Now, I could do the quadratic formula here. I think this seems like an easy problem for me to factor, though. And if I did the quadratic formula, just so you know, your a is negative 16, your b is 80, and your c would be 0, and that would work. I'm going to choose to factor this one. I'm going to take out the greatest common factor first, which is negative 16x. And when I do that, I get x minus 5. I set each factor equal to 0 and solve. So here I get x to be 0, and here I get x to be 5. So that's where those 2 points are that I've circled in green, the 0 and the 5. That's the time there. So time of 0, which we already knew, and this is my time. I'll label it seconds. So the object returns to the height of 200 after 5 seconds. Goes up and back down. Last one we're going to do together. A player hits a ball at a 45-degree angle with the ground with an initial velocity of 80 feet per second from a height of 3 feet above the ground. The equation is represented there. It gives the path of the ball, where h is the height and x is the horizontal distance the ball travels. So height and distance. This is my distance. This would be height. And you think about someone, they're standing at 3 feet above the ground. So let's just say, like right here, this person's standing. And that's the bat hitting it, right, at 3 feet. And then the ball does a 45-degree angle. I'm just going to sketch something that looks like it could be it, right? And that's how it's going. Now remember, it's going to come up and it's going to come back down once it hits that maximum height. So it's asking, what's the maximum height? Again, I'm going to find my vertex. So negative b over 2a, which would be negative 1 over 2 times negative 0.005. And I get that to be x to be 100. Then I plug that into my equation. To find the y value. And I find that at 100 feet, I get 53. It's traveled 53 feet. Or 53, yeah, the height. So my distance is my x value, my height is my y value. So this would be, at 53 feet high, I've traveled 100 feet. That's what that's saying. So the maximum height is my y value, so my maximum height is 53 feet. It says an outfielder catches the ball 3 feet above the ground. How far has the ball traveled when the outfielder catches it? So here in this case, for my problem, my original equation again is this. They're saying they caught the ball at 3 feet. So I'm going to put a 3 in here for that height that they caught the ball at. That's h. So when I do that, I'm going to solve this for x now. So I'm going to minus 3 from both sides. And again, my constant disappeared, right? And then I could choose to do the quadratic formula, or I can factor. I prefer to factor here, so I'm going to take an x out. I'd have negative 0.005x plus 1 equals 0. When I set each factor equal to 0, I get x equals 0 as one of my answers. I'd have negative 0.005x equals negative 1. So when I divide by negative 0.005, I get the answer to be 200. So how far the ball has traveled, it obviously hasn't traveled 0, right? That was the starting point. That was when I hit it from 3 feet. So my ball has traveled 200 feet when he catches it at 3 feet. And if you think about the parabola that goes up, if this is 3 feet where he hit it, this would be the 3 feet where he caught it. So these are reflection points, these two that I would find right here. And then it says if the outfielder misses the ball, how far will the ball travel before it reaches the ground? Well, the ground would be a height of 0, wouldn't it? The height would be 0 for the ground. So I'm going to take that same equation, but I'm going to plug a 0 in for y. And this one, I'm not going to try to factor this. I'm going to actually do the quadratic formula. So I'm going to say x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When I plug that in, I get negative 1 plus or minus the square root of 0.94 over negative 0.01. And I keep going and get the decimal for square root of 0.94. So I'd have negative 1 plus or minus 1.06 over negative 0.01. So when I take negative 1 minus negative 1.06, and then I divide by a negative 0.01, I get 202.96. Then when I take negative 1 plus 1.06 divided by negative 0.01, I get negative 2.96. So again it says if he misses the ball, so I hit the ball with a baseball, we're presuming, right? And the outfielder does not catch it, but it has to hit the ground. How many feet has it traveled? Well, it obviously can't travel negative feet. So it has traveled 202.96 feet. Which, if you think about it, remember how far it traveled if the outfielder caught it 3 feet above the ground? It was 200 feet. So that's about 3 feet below there. That makes sense, doesn't it? We could be off a little bit by rounding. So you could have even estimated that probably. Hopefully those make sense. Remember, you don't have to write these equations. They're giving you the equations. You're just having to apply what you know about parabolas to them. So if you have any questions tomorrow, make sure you let me know.